Have you ever gazed up at the night sky and wondered, is our solar system truly complete? The textbooks tell us there are 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, orbiting our sun in a grand cosmic dance. But what if that isn't the whole story? What if, far beyond the familiar orbits, a mysterious and distant world lurks in the dark, exerting its invisible influence on the outermost reaches of our solar system? This isn't a tale from science fiction. It's a real, unsolved mystery in modern astronomy, a question that has captivated scientists for years. They call it Planet 9, a hypothesized giant planet, cold and dark, never seen by human eyes, yet possibly shaping the very architecture of our solar system. Its gravitational pull may be the hidden hand guiding the strange orbits of icy objects at the edge of our cosmic neighborhood. The story of Planet 9 traces back to 2016, when 2 astronomers, Mike Brown and Konstantin Batygin at the California Institute of Technology, noticed something peculiar. Studying the Kuiper Belt, a vast ring of icy debris and dwarf planets that lies beyond Neptune, they saw a pattern that defied chance. A handful of distant, frozen worlds, Sedna, 2012, VP-113, and others, were all following orbits that pointed in the same direction, tilted at similar angles. This clustering, they argued, was so improbable that it demanded an explanation. Why would these remote objects, scattered hundreds of times farther from the sun than Earth, line up so neatly? The simplest answer: a massive planet, perhaps 5 to 10 times the mass of Earth, orbiting far beyond Neptune. This unseen world, Planet 9, would act like a cosmic shepherd, tugging the orbits of these distant bodies into alignment with its own immense gravity. But if Planet 9 is real, why haven't we found it? Why does this planet, potentially as large as Neptune, remain invisible to even our most powerful telescopes? The truth lies in the sheer scale and remoteness of Planet 9's supposed orbit. Imagine a planet so far away that sunlight there is 1,000 times dimmer than on Earth. At such distances, 400 to 800 astronomical units from the sun, where 1 AU is the distance from Earth to the sun, this world would be shrouded in darkness, reflecting only the faintest glimmer of sunlight. Even with the most sensitive instruments, it would appear as a mere pinprick of light, lost amid the countless stars. Yet evidence for Planet 9 continues to mount. Astronomers point to 3 key clues. First, the strange orbits of distant Kuiper Belt objects. Take Sedna, for example. Discovered in 2003, Sedna's elongated path takes it from near the orbit of Neptune to nearly 1,000 times farther from the sun, completing a single revolution in more than 11,000 years. Other objects like 2012 VP-113 and the enigmatic 2015 TG-387, nicknamed the Goblin, exhibit similarly stretched orbits. The Goblin, in fact, swings as far as 2,000 AU from the sun, more than 60 times farther out than Neptune. These objects all share a key trait. Their orbits seem twisted or clustered together, as if an unseen force is nudging them off course. Second, the alignment of those orbits. When you plot the paths of dozens of these extreme trans-Neptunian objects, a pattern emerges. Instead of being randomly scattered, their orbits cluster along a hidden axis. Statistically, this is hard to explain as coincidence. Brown and Batygin's calculations show that the odds are less than 0.007% that such alignment could happen by chance. Third, detailed computer simulations reveal that the gravitational pull of a massive, distant planet could produce exactly the sorts of orbital patterns we observe. In these models, Planet 9's gravity hurls the orbits of smaller objects into a common direction, while flinging some onto wild, high-inclination orbits, and even ejecting others from the solar system entirely. Despite these tantalizing hints, actually finding Planet 9 is an enormous challenge. Imagine trying to spot a single moving speck of dust in a stadium filled with glittering confetti. The search area spans hundreds of degrees across the sky, the equivalent of millions of photographs. And since Planet 9's orbit is so vast, it creeps slowly against the background stars, moving just a fraction of a degree per year. Detecting such sluggish motion requires painstaking comparison of images taken months or years apart. For now, Planet 9 remains hypothetical. Some scientists are skeptical, offering alternative explanations for the observed orbital oddities. Perhaps these patterns are caused not by a single giant planet, but by the combined gravitational effects of many smaller, unseen objects, dwarf planets, icy bodies, and debris lurking in the outer solar system. Others suggest our observations are incomplete and biased. The known objects might only seem aligned because that's where our telescopes have happened to look. And a few even believe that the answer might lie in a new understanding of gravity itself, an adjustment to our fundamental physics, rather than the addition of a hidden planet. Why does the search for Planet 9 matter? If this world exists, it would transform our understanding of the solar system's structure and history. For centuries, astronomers have redrawn the map of the planets, from the discovery of Uranus in 1781 to Neptune in 1846 and Pluto in 1930. The demotion of Pluto to dwarf planet status in 2006 seemed to close the chapter on planetary discoveries. Yet Planet 9 would reopen the book, showing us that the solar system remains incomplete and still full of surprises. The implications go even deeper. Discovering Planet 9 would shed light on how our solar system formed and evolved. The presence of a massive planet in the farthest reaches could explain puzzling features, like the tilted orbits of Uranus and Neptune, or the apparent emptiness beyond Pluto. It might reveal how gravitational forces shape the Kuiper Belt and why some objects were flung into the distant Oort cloud, a vast shell of comets that encircles the solar system. And then there's the question that sparks our imagination. What is Planet 9 like? If it exists and is several times the mass of Earth, it could be a mini Neptune, a ball of rock and ice with a thick, gassy envelope. Its atmosphere, if any, would be frigid, with temperatures plunging hundreds of degrees below freezing. Could it have moons? Rings? Even in such a hostile environment, could it harbor subsurface oceans, heated by radioactive decay or tidal forces? Or is it a barren, frozen wasteland, drifting in perpetual night? The hunt for Planet 9 is one of the most exciting quests in modern astronomy. Global teams of scientists are scouring the skies, analyzing terabytes of data from observatories around the world. The upcoming Vera C. Rubin Observatory, set to begin full operations soon in Chile, may hold the key. Its powerful camera will scan the entire southern sky every few nights, creating the most detailed map of the heavens ever assembled. If Planet 9 is out there, gliding slowly against the stars, the Rubin Observatory could be the first to spot its faint, telltale glow. But even if Planet 9 isn't found, the search itself is valuable. It pushes the boundaries of our technology, trains new generations of astronomers, and forces us to question our assumptions about the universe. Each step, each new discovery of a distant object, each improvement in our models, brings us closer to understanding the true nature of our cosmic neighborhood. The story of Planet 9 is also a lesson in scientific curiosity and humility. Just when we think we've mapped the solar system, the universe challenges us to look deeper, to search further, to question what we know. The possibility of a hidden planet reminds us that there are still mysteries waiting in the darkness, unknown worlds, unexplored frontiers. Imagine for a moment the night when the first image of Planet 9 is captured, a faint moving dot in a sea of stars. Astronomers would scramble to confirm the sighting, calculate its orbit, measure its mass and size. The news would race around the globe, igniting excitement in classrooms and laboratories. For the first time in generations, a new planet would join the ranks of our solar system. Its discovery would be a triumph of human ingenuity and perseverance, a testament to our enduring curiosity. But even if Planet 9 remains elusive, the evidence already gathered has reshaped our understanding of the solar system's outermost regions. The Kuiper Belt, once thought to be a simple band of icy debris, now appears in the dynamic, complex realm, home to worlds as strange and varied as Sedna, Eris, and the Goblin. Each new object discovered tells its own story, adding pieces to the puzzle of how the solar system came to be. The search for Planet 9 also connects us to a broader cosmic context. Astronomers have found thousands of exoplanets orbiting other stars, some hot and gaseous, others cold and rocky, some orbiting close to their suns, others drifting in darkness. The idea that our own solar system might still hold undiscovered worlds is both humbling and thrilling. It reminds us that even in our cosmic backyard, the unknown still beckons. And what if Planet 9 is not alone? Could there be other hidden planets lurking even farther out? Some theories suggest that the solar system may have ejected planets in its early history, flinging them into interstellar space. Perhaps Planet 9 is a survivor, a ghostly remnant of the solar system's chaotic youth. Whatever the truth, the search for Planet 9 is a journey of discovery. It challenges us to look beyond the familiar, to embrace uncertainty, and to keep asking questions. It is a reminder that science is not just a collection of facts, but a process, a quest to understand the universe and our place within it. As astronomers continue their search, each new observation brings us closer to an answer. Will the next generation of telescopes finally reveal Planet 9's faint glow? Will the patterns in the Kuiper Belt prove to be the fingerprints of a giant planet, or the echoes of a more complex gravitational dance? The universe holds its secrets tightly, but our curiosity is relentless. So the next time you look up at the night sky, remember, our solar system may be more mysterious than we ever imagined. The story of Planet 9 is still unfolding, written in the orbits of distant worlds, in the dreams of those who seek them. Whether or not we find this hidden planet, the search itself is a testament to the human spirit, a journey into the unknown, fueled by wonder and the desire to explore. And as new discoveries are made, whether it's Planet 9 or something even stranger, you'll be part of this grand adventure, witnessing the unfolding story of our place in the cosmos. The universe never ceases to surprise us. Each time we think we've reached the limits of knowledge, a new mystery emerges, beckoning us to look beyond, to dream bigger, to keep exploring. Planet 9 may exist, shaping the outer edge of the solar system with its unseen hand, or it may be a phantom, a clue pointing to even deeper mysteries. But one thing is certain, the search for Planet 9 is far from over. And in that search, we find the true heart of science, not just in the answers we seek, but in the questions that drive us forward, ever deeper into the unknown. So stay curious, keep looking up, and remember, the next great discovery may be just beyond the horizon, waiting for someone, perhaps you, to find it.